Okay, so I'm just looking at the homework we had to build a program that calculated the power of a base. So we asked the user for a base and a power, and we use a while loop to calculate that. So just remember that if I raise a base to a power, it's the base times the base times the base as many times as the power. Right? And that's how we do it with a while loop. So here's the whole program already typed in. I declare my base as a double, my power as an integer, and my result as a double. And I do that so that the user can enter a decimal number for the base, but the power has to be an integer number for this solution to work. So we're going to restrict the power to integers. And result I want to be a double so I can have larger results. They'll hold much larger numbers, and I want to be able to hold decimals. And result I have to initialize to 1 because I'm multiplying these things together. If I initialized it to 0, the result would always be 0 because I'm always just multiplying something by 0. Anyways, as we've done before, I prompt the user to enter a couple of numbers, and then I use the cin object to get those from the keyboard and put them in the variables base and power. And then here I have my while loop. The condition is going to be while power is greater than or equal to 1. So I'm going to keep looping as long as that power is greater than or equal to 1. And then each time through the loop, I'm going to decrement the power by 1. And that's what this minus equals shorthand does. That is equivalent to saying power equals power minus 1. And so that kind of idiom of setting something to its former current value plus or minus or times some amount is so common that you do that we have these special operators. I could do the same thing with result. That is equivalent to saying what I had there before. Result equals the result times base. So these things come up so often where we're adding to something, multiplying to it, that we have this special notation, times equals, and it's the same thing for plus equals and divide equals. Okay, so as I loop through this, each time I am multiplying my previous result times the base and decrementing the power by 1. So I'm gonna go around power times. Once I've gone around power times, I will have decremented power by power times, and it'll be at 0. So then when this does get to 0, this condition resolves to false. The expression evaluates to false, and then I stop doing the while loop, and I'll come down here and I'll print out my result. So let's just build that and run it. Okay, and I will put in 2 and 64 for my base and my power, and that's correct. And then I'll hit return to end. Let me run it again. And this time I'll put in, say, 3 to the power 3, and it's 27. Okay, so that works perfectly. Now what I want to do is extend that. I'd like to be able to do all of that over and over again until I choose to quit instead of having to run the program every single time. So what I'm going to do is I'm going to take what I have so far and I'm going to wrap it all up in a while loop. And then each iteration through that while loop, I'll ask the user if they want to continue or not continue. So all of this is going to get put inside a while loop. I'm going to create a Boolean variable, has user quit, and I'll initialize it to false, and I'm going to set it to true when the user quits. And then I'm going to do while not has user quit as my condition. So I know that's a double negative, but I think that reads better than if I do it the other way around. So while user keeps going, or we're waiting for the user to quit. When the user quits, we set this flag. So I think that reads quite well. It's clear what it is. So while not user quit, while the user has not quit, we're going to keep doing this. And I'm going to wrap all of this, and now I will do this Control-A, K-F to format it. So I can see the indentation shows me that this stuff here, it's indented, it's inside the while loop. And I guess I'll start with that. So I'll initially do exactly what I did before. But then when I finish and I display the answer, then I'm going to ask the user if they want to continue or not. So I'm just going to copy and paste this and then modify it for my use. So I'm going to say, let's say, enter Q to quit. Anything else to continue? So I'm asking to enter a character, so I'm going to need a character variable. I'm just going to call it C when we have a very small scope. I'm using it right here. That's okay to have a less descriptive name, just a single character like that. All right, so I'm going to ask them, I'll say Q to quit, anything else to continue. I'll get the character, and then I'm going to do an if statement, which we learned yesterday. I'm going to say if C is equal to Q, so if they have selected to quit, I'm going to set has user quit to true. And that's it. Now the only thing is I want the user to be able to enter either lowercase or uppercase. So I'm going to use a function from the standard library that will convert lowercase letters to uppercase letters. And it's just to upper. So that's from the standard library, and I just say to upper, and so whatever C is, if they type in a lowercase letter, it converts it to the upper. So this way, they can type in a lowercase q or an uppercase q, and it will set has quit. Okay, so let's build that and see how it works. Run it. So I'll enter a base and a power. Okay, and then it says enter Q to quit, anything else to continue. So I'll continue. I'll hit something else. Please enter a base and a power. Let's say 2 and 2. And this time I will quit with a lowercase q. And I had to hit a couple of extra enter keys because I had this kludge. I don't think I need that anymore because of the way I'm doing my menu. I'm stopping to ask the user for input now, so I don't need to ask for input just to keep the thing open. Okay, so here we go, 2 and 8, 256, and let's go again, and I'll say 2 and 16, And this time I'll do Q for quit, and we quit. So that's a nice little way to, and a first step towards a menu interface. It's a nice little way to wrap what we're doing in a continuous loop that keeps going until the user wants to quit.